right, welcome to class. We're glad you're here. Last week we were talking about, it's the page 6, probabilities, and we're going to get into amino acids. We were in the basics of probabilities last week, so we were just starting into it, and we talked some about the lottery, not because I promote the lottery. Obviously, the lottery is a bad idea. And Rose was like, "You didn't finish for your scriptures." And I'm like, "I didn't finish." Yeah, I got the bell rang. When we consider probabilities, something like the big lottery, the Powerball or the Mega Millions, your chance of winning is like 1 in 300 million. Okay, so people, and I think we mentioned this last week, people have thought, well, I'll go buy all the different permutations of this, and then we will win. And if the pot gets over 300 million, because that's how many permutations there can be roughly, then if we bought them all, we'll have to win. And there's actually been a group that did that one time in Florida, but even that is a losing proposition, because yes, they probably could get the 300, whatever the pot was at that time, but that, when they tell you the pot, and they put it on the signs down there in Florida, that's if you take it over your lifetime, not up front. They only give you part if you take it up front. And so that, first of all, you're not going to get that many millions. Second of all, someone else could have drawn the number the same time, same week as you, and then you'll only get half. And then you also have to pay taxes on this. If you took out a loan, because most people don't have 300 million laying around. I don't know if you do, come talk to me after class and we'll help you invest that better than the lottery. No, it's like, it is just a losing proposition. You're not going to make money. And beyond that, where we did want to get to the scriptures, 1 Timothy chapter 6, verses 9 and 10, but those who desire to be rich fall into temptation, into a snare, into many senseless and harmful desires that plunge people into ruin and destruction. For the love of money is a root of all kinds of evils. It is through this craving that some have wandered away from the faith and pierced themselves with many pangs. So we see here that the love of money, it's not, money isn't the root of all kind of evil. It's the love of money. It's this, I want the millions of dollars. I want to be rich. And wanting to be rich causes people to fall into temptation. And that's the thing about the lottery, and people are like, this will be easy money. And the answer is no. If you do the math, you're not going to win. You might go in there and do some little scratch thing, and you paid $1 and you got 10, but then the next 20 times you go in there and do that, you're not going to get anything. And the answer is they're doing this to make money. They're not doing this to help you.
All those casinos and stuff are really big and ornate. Well, there's no reason for that, because they win.
They win big time.
That expression, the house always wins.
Yes.
The house always wins.
And I know a guy, I worked with a guy, and he ended up, it destroyed his family. He didn't gamble. He was an engineer. He understood the math. But his wife would get to paying the bills at the end of the month, and she would start paying bills and see there wasn't enough money, and so she would go down and gamble with the money to make more to pay the bills. And of course, it wasted it, and there wasn't enough money to pay their bills. And it destroyed their family because she got more and more into the gambling. I've seen other folks. We stopped at a gas station one time going on the interstate, like in Macon, Georgia. And I went in because you couldn't pay at the pump. I had to go in to pay. And there was a line of people going up to the window. And they had picnic tables there. And they were going up there and they were buying tickets. And then they were going around, circling around the picnic tables and scratching them off. But they were back in line. And they just kept going around. And I come up and I'm like, how do I get up to the counter? These people are all in a line and it just keeps going and they're intent on this. And the people behind there finally figured it out and opened up another register for me to pay for my gas. And you're thinking, these people all day long are just sitting here going up there and giving them a few dollars and going up there, and it's like, okay, they're just wasting their money.
I found something, and this is, I guess, like she said, the house always wins. But you know these little things that you go in, especially where kids are, and you get the thing? They can set those things where it only has so much grip or how many buy before anybody wins. I thought that was...
Yeah,
It doesn't matter what a good crane operator you are, you can't get it.
right. You're not going to win at this stuff. The other verse I had written down, Hebrews 13:5, keep your life free from love of money. Be content with what you have, for he has said, I will never leave you nor forsake you. So we should be content. I mean, all of us here, effectively, we are rich. We live in a rich country. We have clothes and cars and nice things. And we should be content with what we have, not looking for more. And so when I talk about gambling, the main point here was that we're talking about big numbers. It's 14 times 10 to the 6. So 14 million is 14 with 10 to the 6 means there's 6 zeros. So 6 zeros equals a million, 9 zeros equals a billion, 12 zeros equals a trillion, and anything past that are numbers the government spends, not, So they start having like 10, 9, 10, 12 zeros. It's a huge number. And if it's a probability, your chance is 1 in 10 to the 6, you're not going to win this. It's not going to happen. And then we're going to get into bigger numbers. That was what this side discussion about the dismerits of gambling was about. So let's go back to where we want to be. We've been talking about the human body and the DNA, and when you get in a cell, it's made of molecules called amino acids. Okay, and these are proteins. They're a carbon, oxygen, hydrogen, and then nitrogen make up these protein groups. So there's different elements that combine to make this protein amino acid. So an amino acid makes up a protein. So an amino acid has to be put together, and then you take blocks of those, they're very small, to make a protein. And a protein is like a one step up in the body's biological process. About 20% of your body is made of proteins. A small protein, they can have different amounts, but a small protein has 150 amino acids in a chain. And they have to be aligned in a perfect sequence and form this folded chain. If they're not in the right sequence, it just falls apart. It just disintegrates. So you've got to get the right chain for it to fold up. So the odds that amino acids can combine to form a protein chain is 1 in 10 with 164 zeros behind it. Okay, so to think that you're going to just randomly have these proteins line up and make a chain is 1 in 10 to the 164th. This is much lower, much lower probability. I mean, I wouldn't even begin to write 10 and 164 zeros on the board. Okay? And it's one chance in that the amino acids are going to form a protein chain. Okay, so if you took it and said, well, look, let's assume, and this isn't true, assume the ocean is full of amino acids. Okay, the ocean is full of salt water, but if it was full of amino acids. So this is back after the Big Bang and you had the Earth, and before you got any, in their theory that you're going to get to this first single cell life form is where they're trying to go with this. So to get there, you have the ocean full of amino acids, which is not true. They do combine quickly, so they can combine in about a second. And so in each little part of the ocean, if they're combining, if it was full of amino acids, they'd be sitting here combining all over every second. If they're not the right sequence, they just fall back apart and they would go again. So if you had this Earth that they would claim is 4.6 billion years old, with an ocean full of amino acids, sitting there combining once a second, and none of this can happen, that would be 10 to the 58th combinations in that 4.6 billion years. So that's a lot of combinations. They would sit here and they'd combine, but first off, the ocean's not full of amino acids. Second of all, that's not enough time because it's going to take 10 to the 164th zeros to get a protein chain, one protein chain. So the Earth being 4.6 billion years old, this is why they got to have the Earth be super, super old to allow time for all of this to happen. But again, it's not going to happen. Okay, so they need a long time, but the simplest living cell doesn't have one protein chain, it's got 300. The simplest living cell, not a complex cell. So again, the chances become even harder for this to happen. So this, it can't be just any random protein, it's got to be 300 of the right ones. Not only do they have to be 300 of the right ones, there are different ones that have to be there. And they all would have to have happened in not over the whole ocean, they would have to happen in one spot within a cell membrane in the right order at the exact same time. Okay, so you're going, that's going to be tough. And then down there at the bottom it mentions National Geographic in their news said all species evolved from a single cell. Their study finds, according to their scientists, research shows the probability humans were created is 1 in 10 to the 6,000 zeros. Okay, so we were struggling with 1 in 6 zeros with winning the lottery, and this is 1 in 6,000. And that's their study. They're going, here we go. There's no chance this happens, but our study proved that's where humans came from. And you're like, you apparently don't understand probabilities because your study just said, no, it didn't happen. Now, another person named Theobald looked at the statistics closer, and he argues the odds are only 1 in 10 to the 2,680th. And that's if things arose independently. So that's a lot better chance that happens than 1 in 6,000. I'm sorry, this is, if any of these folks claim they're scientists and they're believing this happened, they're not, they either have no math skill or they just don't have anything better. So the probability that, and this isn't the probability, I mean, when they say it's 1 in 10 to the 6,000th, that's kind of their math on a human coming out. Obviously, they don't know exactly, and that is, again, a lot of assumptions, like oceans are full of amino acids, and this single cell atom can happen and live.
So what is the account or theory of, is that just for developing one person, these probabilities?
Yeah.
So obviously there's going to have to be 2 people
Right?
to develop so that they can reproduce.
Yes.
And I've never thought about that, but this is specifically, those chances are just talking about 1.
Mm-hmm.
And so then your chances of it being 1 male and 1 female, that would make them longer.
much, much worse.
Yes.
And we're gonna talk about, in a few weeks, we're gonna talk about evolution and their current theory, and to me, again, there's no way, okay? What they've proposed, they gotta have something, I understand that. If you're them, they come up with their theory. When I was in school, it was labeled as the theory of evolution. Nowadays, by law, they can't call it that, because calling it a theory is giving into, you're not following separation of church and state. And so the courts have ruled you can't talk about the creation in schools because of separation of church and state, which is incorrect anyway. But that's where they're at. I understand. So they don't call
I read
it.
somewhere, even if something has a chance, well, less of a chance at 1 in 10 to the 40 or 10 to the 50, under probability, you can safely say it won't happen, ever. If you
Yes.
talk about something that's 50 or 60 times less likely than that, so, you know.
Yeah. We're at the level here that you get this many zeros, anyone that studies math or science would go, no, that didn't happen. That's not it.
I think rather than calling it the Big Bang, you have to call it a nuclear bang or something. Big don't.
Yeah, they're, and we had started out, I know a few people weren't in here, but when we first started out, we talked about that Hebrews 11, 1 through 3. Now, faith is the assurance of things hoped for, the conviction of things not seen. So, yes, we have to have faith in what the Bible tells us. We have to believe things we can't see. Their faith has to be much greater than ours, because they have to believe in things they can't see either. They've never seen amino acids combine into a protein. Never happened. They don't see that happen in the lab. They have to believe in things that are unseen as well. Their faith actually has to be much greater than ours, but that's a different issue.
Sorry.
Okay. Let's move on to page 7. And this is, we're going to talk about, we talked about the case of God as the designer of the universe already. And now we're going to talk about the human body. Okay, so we talked about DNA and the chance of a protein. And now we're going to talk about the human body, or the human body's great designer. So when we think about the human body, it's composed of tissues, organs, and then it's like you build up from cells to different types of tissue. And there are numerous kinds of tissues in the body. They're about, if you think about it, there's like muscle tissue, nerve tissue. There's 700 muscles, and they're not all the same. Muscles are like 40% of the body, of our body's weight, and they're like our body's engines. There are two kinds, are classified as voluntary and involuntary. Voluntary are ones that you control, like your arm. Your brain has to tell your arm to move. Involuntary are ones that your brain doesn't tell what to move or to do things. And so involuntary are ones like your heart. You don't have to think about your heart and go, beat faster, I'm fixing to run. No, it's automatic. And we will probably get into some more detail on the circulatory system. But I was studying the other day, I got on the side thing. My watch will do your EKG. And I'm like, cool. And then they'll tell you, okay, you have sinus rhythm. And I'm like, yeah, I'm breathing. And I'm like, well, but when they say sinus, I'm thinking head, and they're thinking other stuff. I don't know what that means exactly. So I went on YouTube to learn how to interpret my EKG. Because I'm like, well, I got it, I should see what it says. Well, the first video I hit was some doctor, and it was like a 12-part series of hours each time on how to do it. I'm like, no, I need the 5-minute version. And so then I found some nurse that explained the 5-minute version. But what I did learn from the doctor, because I watched the first hour, was really cool, because up at the top of your heart, there's the place that starts the pulse, and then it goes down through this nerve thing bundle in the middle, and then it splits at this node, and then it goes down along the sides, and then it goes on around. And so the pulse for your heart to beat is start and moves through these different places. Well, each of those other places has fail-safes. So if it doesn't get from where it's supposed to start down to that first node, then your heart will still beat, because it has a backup system, but it beats at a different rate. And if that doesn't work, then it like moves down to the next chain, and it will beat at a different rate. And it's sort of like if your heart rate is like 40, then it meant like all these other things are failed, but you're in backup mode. And I thought, now this is a cool design. When you think about our human body and how complex, to think about something like your heart and it having multiple backup modes, this is a great design. And that's the whole point about our body has a designer. It's not a random, a random thing. So we've got these different kinds of muscles. Sorry for getting off on that. Our heart is involuntary. Our intestines are both. Some muscles are both, like in your eye, the muscles that control your eyelids. You can make your eyes blink, but they all do it automatically. Okay? We have 3 types of muscle tissue: skeletal, which is attached to your bones; cardiac, which is a different kind of muscle. Your heart is a different kind of muscle. And then you have smooth muscle cells that are in the walls of the blood vessels, because just to pump your blood is more complicated. To get it back up from your feet to your heart, the vessels actually have to squeeze in and push it back, okay? So muscles work by tightening, like in your arm. They shorten or they pull. There's more complicated than just, I got muscles in my arm or my leg. There's, as your muscles increase in strength, you can tell I'm this bodybuilder, right? Now you see these guys that got giant muscles, right? Well, their bones have to develop as they sit here and work out at the gym lifting weights. Their bones get stronger too, automatically, because if they didn't, my arm would snap off if I tried to lift 400 pounds, right? It would be, if something's going to break, it would be a bad day. So where they're attached, the ligaments, all of that modifies as you work with your muscles. So you can make your muscles bigger, but you also modify, the rest of your human body with that as well. And as you, like a runner, Stuart's a runner, well, your legs get stronger, but they get more tone. Okay, it may affect your knees, it may affect your ankles, but also it's going to affect your circulatory system and your respiratory system. That all works together. As you run, you make those stronger. And so we can affect our whole body. It's been said that the best scientists in the world, most gifted, probably could not come up with a stronger or more perfect tool for grasping and manipulation than the human hand. You just couldn't design, a great designer, a human designer, couldn't design something better than just our hand.
I was reading judges that had an IBZEC that would cut the thumbs and the big toes off of people he captured, because then they couldn't do anything hardly with their hands anymore. That's just how important that is.
Right.
They couldn't even scrape up the crumbs under his table, it said, or they were captured.
Yeah. Well, and that's great. I had this quote, Sir Isaac Newton I think he invented Fig Newtons, I think. He remarked, in the absence of any other proof, the thumb alone would convince me of God's existence. And you're going, okay, when I look at my body, this is not the high point, but
How could you get a ride?
yeah.
Well, if you think about, like, when I taught that class on judges, I said, get out your phone and put your thumb back here and try to do anything, even on a cell phone, like text, or, you can't, it's hard to do, a lot harder. You just don't
Right.
realize all the things you grip with your hand, take it for granted.
Well, and I've noticed, you know, you're getting old, it's like, but the iPad or the phone,
Yeah.
my left thumb will get where it hurts from doing this, and I'm like, these kids,
Yeah.
about 50 years from now, their front thumbs are gonna be paralyzed. Because you watch how fast they are, and it's like, you know, I've only had a phone for, a smartphone for a few years, you know, a fraction of my lifespan. You know, what, I don't know, 20 years, 10, 20, I don't know.
I think that actually is a thing, that younger people are having trouble with their phones.
Cell phone,
Yeah,
like tennis cell phone.
Yeah.
yeah. And
Yeah, when I was growing up, you got tennis elbow. Now, so we think about tissues like muscles, and then the next step is organs. So our body's got organs. Okay, so what is the largest single organ of the human body?
Skin.
Skin.
The skin. Right. I'm telling this to people that know more than I know. Before we jump into it too, well, we'll talk about skin, then we'll get to our verse. I've tried to, some of this I know is more science than verse, but, you know, we're gonna, I think after we get past human systems, we're gonna talk more about, we're gonna have a week that's a little more Bible than science. So the skin is the largest single organ. It has layers, it has glands, you have your nails. The outer layer is the epidermis. It's about 0.1 millimeters thick, so it's very thin. The outermost layers are dead. They're just kind of protecting it, constantly getting new cells. The lower layer, the dermis, contains connective tissue. It's kind of spongy or leathery, between 1 and 2 millimeters thick. It protects your body, it cushions your body, it keeps all your stuff in, you know. It has hair follicles, sweat glands, sebaceous glands, I have no idea what those are. Nerve endings, capillaries, and lymphatic cells. So you got all of this stuff in your skin.
And it heals itself.
It heals itself. It has the nerves, the receptors that are there that feed your nervous system. And there are tons of receptors. There's 1 square centimeter of skin has 6 million cells, 100 sweat glands, 10 of those sebaceous glands. They must be good because there's 10 of them. 5,000 sensory corpuscles, 200 pain points, 25 pressure points, 12 cold sensitive points, and 2 heat sensitive points. A lot of stuff packed in the one little part of skin. And it lists here in the book, like there's 10 things that your skin does for you. It's like everything from being this waterproof wall around your body, you know, it's keeping germs out. It protects your rest of your interior stuff from bruises. It protects you from UV, the melanin, excuse me, shields you from the sun, the UV, and you think, well, okay, you know, the inner part of your body's needs UV protection, okay? We can sense, touch, cold, heat, pain, pressure. It's a major sense organ. All of these things that it does for us. And then you think of something when you go from there to, you know, your skin, and then you go to just something like your fingernails and your toenails. it's like a horn type material, protects the parts of your body that would normally get damaged. And I know that, you know, you get little cuts on your fingers and they heal up, you know, you get a paper cut, but think if you didn't have a fingernail, you'd have 10 times as many of those things going on. 'Cause-
20.
Yeah,
Toenails too.
I mean, I mashed my finger the other day. Had these two magnets, they're real strong magnets, and I'm using them, putting them in a project, and it jumped. I was holding the stack of them, and I was trying to figure out if it was north or south, and it jumped over there and mashed my finger, and I was like, okay. Your fingernails protect you. Then you think of something like your hair. Some of y'all have, all of y'all have more than me, even Tom's got more than me. Okay, so your hair can be a sentry. Your eyelashes warn your eye when something, you know, is flying up there and make your eye close quickly, and it keeps a bunch of stuff. You know, yeah, you can have a particle that's flying too fast for it, but normally, I mean, you've probably had like a gnat get up there and fly around and hit your eyelash, and it helps protect you from that. So your body is protected by your skin. It detects things. It can sense multiple things at one time. You know, it's not like your body can only go, well, I'm a little hot right now. It's like, no, you can be sitting here going, you know, my hands are cold, my feet are cold, but you know, I'm okay, you know. It can sense if one part is getting hot, you touch something hot, and the rest of you might be cold at the same time. So our skin is, I guess, mundane as that is, it's still very complicated. It's a great design. So we're gonna move from it to something a little more complicated, our eye. But let's look at these two scriptures. We could study any of the complexity of human organs and see a great design, a designer greater than any human. Psalm 94:9, and this is talking about God. He who planted the ear, does he not hear? He who formed the eye, does he not see? And then Proverbs 20:12, the hearing ear and the seeing eye, the Lord has made them both. So it just tells us in the Bible, God has made these things for us. He has blessed us with ears and eyes. So if you look at the human eye, and we're gonna talk about Charles Darwin some more when we get down to the origin of species and evolution, because he was kind of the father of that. There's a paragraph there where Charles Darwin stated in 1859 that he basically is saying to suppose the eye with all its, you know, contrivances, the ability to focus, control for the amount of light, correction of spherical and chromatic aberration. Okay, so if you have a lens, the camera here or the camera in your phone, spherical aberration means when you take a lens and you shoot a picture of something, if you get close to it with your camera, it will make, instead of the page looking square, it kind of makes the edges look curved. Okay, you may have noticed that with your cell phone camera. A better lens, a more expensive lens, will correct for spherical. Okay, chromatic aberration, sometimes you'll get with maybe your phone camera, if you shoot a picture and you'll see a very thin, maybe sort of a purplish line around, like if you shot a picture of a house with the sun behind it, you'll see a little, like 1 pixel wide little outline on it. That's chromic aberration, and that your eye corrects for this. Your eye does grade. Okay, so he continues on. It could have been formed by natural selection, seems, I freely confess, absurd in the high sense. So Darwin himself confessed that it's absurd to think that your eye happened by evolution. It did. He knew better. Now, he did he did argue, obviously, that humans were natural selection and part of evolution, but he looks at the eye and he goes, well, this is too complicated. Evolutionist Robert Jastrow wrote, "The eye is a marvelous instrument resembling a telescope of the highest quality, with a lens, adjustable focus, a variable diaphragm for controlling the amount of light, and optical corrections for spherical and chromatic aberration. The eye appears to have been designed. No designer of telescopes could have done better. How could this marvelous instrument have evolved by chance through a succession of random events?" He also stated, "It is hard to accept the evolution of the eye as a product of chance." So you have people who are evolutionists that are like, the eye is too complex to happen by chance. The eye processes about 80% of the information we receive from the world. They can handle 500,000 messages simultaneously. In the average day, your eye moves 100,000 times, and it has the muscles of your eye per weight are the body's strongest. So they're little bitty, they don't weigh anything, but they're the strongest. Your body would have to walk 50 miles to exercise the leg muscles an equal amount of what your eyes muscles do in a day. And that would be tough. That would be 50 miles would be hard for a week. You think about not just that, but there's tear ducts produced exactly the right amount of fluid to cleanse both your eyes simultaneously in 1/500th of a second. And there are people that, develop problems and have dry eyes and have to take eye drops, but you think for every person doing that, there's millions of people and their eyes, it's like it works good. Your retina has 400,000 optical sensors in about a square millimeter. It's like, you think about the complexity, how much detail your eye can get, and it's easy to compare it to a camera. I mean, I didn't bring a still camera. I mean, I've got one on my phone, but you look at the Nikon film camera, and it's like, I love cameras, I have a lot of cameras, but you look at it and just the precision, the machining, you've got the iris, you can turn the ring for the f-stop, well, your eye stops up and down automatically. So when you go outside in the bright sun, and when you come into your house and it's sort of dark, your eye makes up for that. It gets a little slower as you get older, but it fixes that. Your eye can focus far and close, quick as a camera could. A best designed camera looks at somewhere around 40 or 100 spots to focus. Your eye focuses on the whole image. It is got a better dynamic range. If you take a film camera and you look at just the scene, and you've got the bright light, the bright white of the house over there, or the sun coming in on the floor, and then you've got the darkness underneath, in the closet over there, but you can still look in the closet and see the wheels on, a rack to hold tables. And you can look over here and see the joints of the floor in the bright sun. Well, that is much, much brighter than over there. A camera, if you shot a picture of this, either the closet's going to be black or the floor is going to be just white with no detail. It can't handle the range of it. So we have like the best camera design ever. Then you think about how the information gets from your eye to your brain. And this I learned, this was new to me. Okay, you know that because it went through a lens, the image is upside down and backwards. Okay, no big deal. Your brain's used to that. It decodes that. No, that's not a problem. Okay, but I didn't know is your optic nerve for each eye splits in half. And so half of the image of your right eye goes to the right side of your head, and the other half goes to the left side of your brain, and then your left eye does the same thing. And so it splits the image into halves. I don't know why. But your brain puts it all together, and there's not like a line down the middle of like where you look around, right?
It happens like instantaneously. It doesn't like have to think about piecing all that together.
Right.
Yeah.
But how would evolution or a human designer would not take your optic nerve and go, hey, this will be cool, let's split it in half and put half over there and half over there, that'll be fun.
And then put
Well,
together.
yeah, you wouldn't do that. So the human eye can make images, it can focus near and far, it can do it better than any camera. It has rods for black and white. You know, when you think of a camera, you have black and white film, you have color film. Your eye does both. Your brain is the processor, like in a digital camera. The iris is like the of your eye is similar to one in a camera lens. Your auto focuses. It can do wide angle. You have peripheral vision, but you can also focus on a small spot. So, granted, you can have trouble with your eyes, but your eyes do great things. Let's talk about the ears a little bit. We got just a few minutes. The human ear has three areas: the outer ear, the middle ear, and the inner ear. There's an eardrum, a thin membrane to keep water out of your head, which is a good thing. You got the three little bones in there, and there's technical names for those. Someone here probably knows those, but we always call them the hammer, the anvil, and the stirrup because what they were shaped like.
She knows.
I think it's the malleus, the incus, and the stapes.
Right.
I'm gonna have to change seats.
So they're designed to transmit the faintest sounds. And it goes through another membrane into the cochlea. There's 25,000 auditory receptors. Your ear, the size of a hazelnut, has as many circuits as the telephone system of a good-sized city. And as someone would go, could you assume that the telephone system of Paducah didn't have a designer? No, you can't. It had to have a designer or it wouldn't work. And our ear does more than that. Our ear is more sensitive than the most sensitive microphone. So if you think about the microphones for the sound system, our ear is better than the best microphone you can buy. As the scientist said, it represents the ultimate limit of performance. Not only does our ear hear, but it's got other tubes in there that have liquid in them, something like paralymph, I probably mispronounced that maintains our body's equilibrium, so it keeps your balance. So your ear lets you hear, and also keeps your balance. So it's like the guidance system of a missile or a submarine. As was stated by a man named Linehan, the combination in such a small space of the hearing and balancing system of the body represents a remarkable achievement of biological engineering. And then again, I'm just going to go back. I know the bell's about to ring. Proverbs 20:12, the hearing ear and the seeing eye, the Lord has made them both. And we know that. We know that God has given us these as a gift and blessed us with these. Any comments on hearing or seeing? You know, evolution may have given us the ability to not hear things when we want to, but other than that,
I think that's practice.
that's, yeah, practice. All right, I'm going to stop this.